This is Lecture 8 in the FOA series on premises cabling. Lecture 8 covers coax wiring practices. Coax isn't covered in most premises cabling standards, but it's widely used for premises cabling, and any good premises cabling tech should know about coax. Coax cable is called coax because of its coaxial construction. Instead of twisted pairs, it has a center conductor covered by a dielectric, an insulator, that locates the center conductor in the center of the cable, covered by shielding, and then finally a jacket. The shielding is one of the important things because it keeps the extraneous signals from radiating from the cable. The shielding is usually a combination of foil of some metal, usually aluminum, covered by a wire mesh, which is the outside conductor. The inner conductor is often stiff because it's used as a center pin, for example in type F connectors. The two connectors most often used with coax are the BNC and the type F. The BNC is a bayonet lock connector, typically used for cables like RG58 and RG62. It uses a separate pin for contact because some of those cables have flexible center conductors. The F cable is designed for cable TV and satellite TV and uses an RG6 cable, which has a solid center conductor that becomes the pin for the connector, simplifying termination. The termination process for coaxial cable involves several steps. The first is to strip the center conductor and expose it, then to strip the jacket to expose the shield, push the connector on, and crimp it. There are alternative methods of holding the connector on, including screw-on connectors that just simply screw onto the jacket, and compression connectors, which are the prized ones, the best ones, because they make the best contact with the shield. Special tools are used for stripping coax. It's a two-step process. The first step is to remove everything down to the center conductor. There are many types of strippers available, like this inexpensive one here. But you have to adjust them to make sure you get a full cut, but don't nick the center conductor. After cutting with the stripper, remove everything down to the center conductor. It sometimes helps to twist the foam core to break it loose from the center conductor. The cable should now look like this, so you can see the center conductor and the rest of the cable following. The length of the center conductor is determined by the connector, but it's usually about 10 millimeters, or 3/8 of an inch. The second strip is merely to remove the jacket of the cable, but making sure not to damage the shield braid. Then you peel off the jacket. After removing the jacket, fold the braided shield back over the jacket to contact the connector body and become the outer conductor. Leave the foil on the foam dielectric because that helps reduce electromagnetic emissions from the connector and holds the center conductor in place. Then you simply push the connector on the cable to the proper depth. The pin should protrude slightly. Crimp the connector with a die specified for the connector, and in fact the type of crimp tool if you're using compression connectors. Some connectors require 2 crimps for proper crimping. Here's your finished connector. You can use a compression fitting type connector or a screw-on connector. Screw-on connectors are a cheap and dirty solution. They're not as good in performance, especially in terms of electromagnetic emissions. You generally only test the continuity of a coax connector with an ohmmeter or a special coax cable tester. The typical problems are opens, where there's no contact on the connector shell from the braid, shorts, where wire braids contact the center conductor, or kinking, We didn't talk much about installing coax cable because it's just like installing any other cable. But because of the particular construction of coax cable, it's very sensitive to kinking. If you kink the cable, you may affect its high frequency performance. So like every other kind of cable, be very careful when installing it not to put kinks in the cable. More information on premises cabling can be found in the FOA online reference guide. Go to the FOA website, www.thefoa.org, for more information.